And for this next talk, I want to bring on Vitalik to do a 1 year later review of a blog post he originally wrote talking about the promise and the challenges of crypto and AI. So January 30th to February 7th, 2025, a lot has changed. And Vitalik, welcome.
Thank you. Great. So a year ago, right, I wrote this blog post that was on the intersection between crypto and AI. And at the time, of course, that area was still very small. And I think, there have been a lot of people that had tried to force the two things to come together. And a lot of the time there's a challenge in actually making the combination work, right? But of course, since then, AI has become powerful enough that AI has basically been well on its way to eating everything. And so, we've been seeing crypto and AI intersect quite a lot in the last year. And so I thought it would be valuable to look at some of the predictions that I made about crypto AI applications in a year ago, and then basically see, well, where are we today, and can we say something more definite about some of these categories, right? So in the blog post last year, I described 4 categories of crypto AI intersections, and I categorized them as AI as a player in the game, AI as the interface to the game, AI as the rules of the game, and AI as the objective of the game, right? And basically, the first two are AI is participating in, well, the first 3 are AI is participating in blockchain constructions, and the last one is, of course, blockchain constructions helping to build or improve or maintain AIs, and sometimes you actually need to do both at the same time, right? And the thing that I said last year is basically that the first one, AI as a player in the game, is actually the category that is the closest to being able to really seriously launch and get adopted. And I even made the arguments that actually we've had an AI crypto intersection use case for almost 10 years, which is arbitrage bots trading on DEXs. And if you think of that kind of category as a starting point, then you can ask the question, well, what other kinds of games, on-chain games, potentially off-chain games, can AI participate in? And then the other categories are a little more still blue sky and still dependent on further technology. But of course, AI is improving quickly, and we've also seen cryptography improving quickly as well, right? So let's talk about AI as a player in the game, right? So the OG AI crypto intersection use case is arbitrage and market making on decentralized exchanges, right? And since then, of course, we've seen AI evolve from being relatively simple algorithms to being primarily LLM driven. And so in 2024, we've seen a lot of Twitter bots, also, of course, Farcaster bots and other kinds of bots as well. And we also saw last year a couple of experiments in some interesting areas, right? So AI's participating in prediction markets. So Martin Koppelman and Omen, together with Otto Nolas and that whole cluster, basically tried to do AI's participating in prediction markets, and that was pretty interesting. And so the question is, well, what are the kinds of games that we can make this year that AI could participate in as well, right? So I'll say something more definite this year than I said last year. And the definite thing that I want to say is basically that I think one very particular unique opportunity is AI DAOs, right? So DAOs, they've been part of the dream since basically before the beginning for Ethereum, right? So I think I literally wrote the 3 posts on decentralized autonomous organizations in Bitcoin Magazine, literally right before I wrote the original Ethereum white paper. But then, of course, we've seen DAOs have a lot of problems. And I think a lot of the problems come down to the fact that there's a lot of things that need to be decided. And you basically, you end up very easily having low quality decisions, right? So the question is, well, can we have higher quality decisions? And actually, on top of the low quality decisions problem, one of the other problems that's starting to pop up recently is this bribery problem, right? Like there's like an actual thing, I think it's like literally called Bribe DAO or something like very similar. And it's like becoming one of the largest delegates in Arbitrage DAO. Like basically people are like literally doing like bribery and turning coin voting into auctions, right? So can we make AI mechanisms that are both more high quality in decision making in peacetime and more resistant to capture in wartime? And so the core generator of ideas that I'm using here in this paradigm is this concept of AI as the engine, humans as the steering wheel, right? So humans are there to provide some kind of like alignment, provide some kind of value signal, and AI is basically just there to optimize, and the optimization is guided by the signal that the humans provide. So this can be done in a few different ways, right? And I think a lot of the time, like people just tend to instinctively gravitate toward this approach where you just have a single AI model and you have humans somehow feed their preferences into the single AI model. And like you can do that, right? That's like an intuitive and easy construction to understand, but it's also a construction that I think has a lot of pitfalls. And we'll talk a bit about exploitability a bit later. And the other pitfall is that realistically, AIs are going to improve, and like the optimal design of an AI is going to be completely overturned pretty much every 3 months from here all the way up to the singularity. And so, like, you want some kind of function that accommodates new AIs being able to come in and like basically being able to upgrade the engine without that upgrade process itself being a strain on the decision function, right? And so I've suggested these two other ways of achieving the same goal. So one of them is, of course, old idea from Robin Hanson and many others over the last decades, futarchy. Basically, humans vote on an objective function, and the prediction market, which I think realistically can be played by AIs, can identify which decisions could optimize the objective function, right? So the standard example that gets used to illustrate this is like the fire the CEO market. Basically, you create a 3 markets. One of them is a prediction market for will the company fire the CEO. One of them is a token that gives you 1 share if the CEO gets fired, and one of them gives you a 1 share, and the third one is a token that gives you 1 share if the CEO doesn't get fired. And then you can basically divide one price by the other, and you can get the market's implied expected share price if you fire the CEO and the expected share price if you don't fire the CEO. And then, like, basically based on whichever price is higher, you make that decision, right? Now, of course, like, a thing that's really important to caveat here is that like share price is not the only objective function, right? It's like a very natural one in a for-profit context, but we create organizations for many different purposes, and we want like some kind of like whatever your objective function is, which for a country it could even be something more complicated like average self-reported happiness plus the exponential of life expectancy over 10 plus cube root of GDP. Like you could basically go crazy, right? You should probably combine different metrics. Like basically you have humans that decide what that objective is, and then you have a market mechanism that tries to optimize for that objective, and realistically AIs end up playing, right? And the reason why this is sort of aligned is that if you have an AI that is wrong, right, so that identifies decisions that don't optimize for that objective function, then it's going to lose money in the market. And actually, an incorrect participant coming in creates the incentive for correct participants that could come in and even put more funds in order to take their money, right? And so, in a sense, like any attempts at manipulation actually pays for countering the manipulation. Distilled human judgment is this other idea that I've been suggesting recently, where basically, the idea is that if you have a large number of decisions that you need to make, a human jury provides answers to a random subset of those decisions, and then you have AI models that provide answers to all the decisions, and you choose the linear combination of AI models that is the best fit to the jury answers, right? So basically, people submit, AI submit all their answers, and then humans, they're only providing potentially a few hundred bits. And so humans could potentially spend like an entire 5 minutes, potentially even 30 minutes or longer on one single bit. You make sure each individual bit is high quality, right? So you think of it as being like a court system. Court systems output relatively few bits, but they put a lot of effort into each bit. And then AI becomes this like low effort, hyper scalable thing that tries to like do a best fit to approximate what the human jury does. And so deep funding is an effort to try to apply this to a graph where the question you're asking is what percent of credit for thing X goes to thing Y. So what percent of a credit for Ethereum goes to Geth? What percent of credit for Geth goes to like some particular library dependency, and so on and so on. And the idea is that you could use this for things like retro funding, right? You basically just like have AIs create this graph of who deserves what percent of credit for what. And then any funder can just come in and say, click, I want to support this node because I believe, Ethereum is good, or I believe Geth is good, or I believe, cryptocurrency is good. And then the credit automatically gets broadcasted down recursively to all of the nodes that were upstream of it. And the goal of this is to basically have something that's able to surface potentially multi-layer dependencies, potentially dependencies that are difficult to detect without needing projects to engage in popularity contests. Distilled human judgment for community notes is like one of those ideas that I've suggested, right? Or you can think of it as like distilled human judgment for like social media posts in general, right? So with community notes, it's a lot of people love it. When people criticize it, usually the number one criticism is that it's too slow, right? By the time a community node appears, everyone's already seen the misleading content. And so the question is, well, can you create an incentivized market of AIs that try to predict which posts will get community noded in real time, right? And so in all of these cases, these are all examples of this AI as the engine, humans as the steering wheel paradigm. And what they do is they allow for a highly distributed DAO to, instead of asking each person to have an input on thousands of decisions, which leads to either low quality or on decisions, or like 1% participation rate, or everyone outsourcing to delegates to get centralization back. Instead, you have each person providing a much smaller number of inputs, either through a random sample mechanism or through like a futurity type objective function. And then you have AIs that use that as a signal and try to create optimized decisions for everything else. So basically, I think this is like one approach that's really worth trying and seeing, maybe this can be the public governance mechanism of the future, and maybe this is one really valuable way to try to make DAOs great again, to try to make public goods funding great again, and a lot of other things. AI as the interface to the game, right? This is and one of those interesting ones. So, I mean, people use the word agent a lot, and I don't know. I personally always feel like unease with the word agent because it implies sort of one particular form factor, and it implies that at least to me, this kind of long-running autonomy is the thing that we're striving for, when I actually don't believe that, right? But of course, in reality, the word agent gets used to apply to basically a whole spectrum of AI related applications, where basically the AI can make kind of one or multiple calls out to other services after you give it an instruction, right? This cute little cartoon is actually from Salesforce, which recently released this very lovely marketing branded thing called Agent Force. And so everyone's getting in on the game. I'm an agent, you're an agent, everyone's an agent. But I think if we want to think about it more concretely, right, that basically, the challenge here is that people need help interacting with the blockchain world. And there's lots of different contracts that you can interact with. And potentially, yeah, AIs can help users discover smart contract systems that they might want to interact with for a particular function, help users evaluate their security and participate in them. Potentially, you could even have something that like activates once in a while and sort of serve this kind of watchtower function, so they do something if something goes wrong. And basically, yeah, make it easier to interact with the whole crypto world. And I think it also has this other interesting consequence, which is that like the interface, the AI logic is not something that is being provided by whoever wrote the smart contract system, but rather it could be provided by a third party or potentially provided by something that is more aligned with the user, right? And so I think it has these interesting political implications in terms of who has certain forms of power in interaction with a DApp, right? So I think this is something that's really worth exploring as well. AI has the rules to the game, right? So this is when I go back over here, right? This is the concept of like, let's have a DAO where we just make a single AI model, humans feed it their preferences, maybe just feed it in a text file, and then the AI model just goes and actually runs things, right? So the concern I have with a lot of this is that it's very easy to underestimate the exploitability of these things, especially if they are open source, right? So there's this entire science called adversarial machine learning, where basically you can take a model and then you can gradient descend attacks against that model, like basically tiny things like random bits that you can insert that optimize for tricking the model into believing something false about what it's seeing, right? And so this is like an attack that was trained against one particular classifier. And so, you start with a cat, you add a tiny bit of random noise, and it's a cat that it thinks is a dog, right? And it's actually fascinating how sophisticated these attacks can get. Like there was one that was used against facial recognition models where the attack was actually made in the form of a mask, like a mask that you can wear, like a face mask, that doesn't actually cover that much. And there is a version that makes the security camera think you're not a person, and there's a version that even makes it think that you're a different person, right? And if a model is open source, that actually makes it easier to train attacks against these kinds of models. So how to fix this? There's many ideas that depend on cryptography. Currently, this stuff is pretty far away from being sufficiently efficient. FHE and all that stuff has overhead that's very high, but we will see, right? And so one approach is to try to work on cryptography, potentially work with TAEs, potentially other things, and try to fix this kind of issue. But the challenge is you're solving for two problems at the same time, right? You want the model to sort of be closed enough that it's not exploitable, and you also want the model to be open enough that the participants have confidence that whoever created the model did not themselves insert a bug that lets them eventually take out all the money, right? And so there are cryptographic ways to get the benefits of both, but it's a challenging game, right? And this is one of the reasons why I'm personally really interested in trying to encourage more development in these approaches, where instead of enshrining a single AI engine, you're creating an open market of AI agents where it's a free entry ecosystem where anyone can join and they're being judged against this value signal that's being provided by humans. AI is the objective of the game, so using crypto to create AIs. So we're seeing some distributed trading runs happen. I'm not seeing much progress yet in this idea of using crypto technology to get stronger guarantees about what's happening in a trading run. I think one of the challenges is that a trading run is just really expensive, and any cryptography adds an extra cost on top of that. But I think it's interesting to start thinking about these things too, right? So conclusions, right? I think in the short term, the biggest focus is on this spectrum between AI as the player and AI as the interface. And I think one place where I was wrong last year is I thought about player and interface as being two separate categories, right? And I think the reality is that it's actually a spectrum, right? You can have a system where AIs are relatively highly autonomous, and it's like a script that just goes and does its thing. I mean, even like market maker bots, they've been mostly autonomous for the last decade or so. But then on the other hand, you could also have AIs that are like very active, that are very engaged, and that are constantly getting inputs from their user in terms of what they want and what they don't want. And the reality is like there's a sliding scale of how much input the participant is providing, right? So AI as a player in the game, AI as the interface to the game, I think is really the place where we want to look. And I think there's a unique big opportunity in governance. So AI DAOs, AI-based deep funding. So I recently made a demo. If people want to just like play around with deep funding ideas, if you go to github.com/deep funding/scoring, I have a couple of fun demos there that I'm going to show what deep funding might look like in action. And it's just like experiment with some of these ideas. Of course, experiment with futarchy as well. And I think there's some really valuable stuff there. And then, of course, in the future, we continue to work on the Egyptian god cryptography to try to make, the other AI crypto intersections more efficient, and work on the other things as well. Wish everyone trying to build AI applications on Ethereum the best of luck.
See, oops, I think we lost your video.
Okay.
We'll add you back on. There we go. It was an interesting kind of way to summarize a lot of what happened. The thing I'm kind of curious about is knowing, has that kind of changed your thinking on what the EVM needs to do to adapt a lot of these applications, or do you kind of still believe that a lot of this is around the fact that we should happen off-chain, and we should think about the blockchain for preserving the data integrity versus enabling the liveness or the execution?
I think realistically, not too much, right? Like if you analyze some of these existing these ideas for applications, right? You have whether it's DeFi or whether it's prediction markets or whatever. It's like ultimately still you have transactions. Transactions are going on chain. I mean, maybe there is an argument that this means that scalability needs to go even higher, right? Because with if AIs are going to participate in prediction markets, then they'll be willing to do that even if the expected return from a transaction is 1 cent. And so there's value in the transaction fee being 0.01 cents instead of 0.1 cents, right?
No, that makes sense. I asked this question to an earlier panel with Ilya and Ed from Arbitrage, and kind of the question was around understanding what are some interesting ways to think about leveraging zero-knowledge proofs here, the world of agentic execution. And I'm curious if you have any thoughts around how do you see the overlap of AIs and ZK, because we've seen a lot of TEs being the way to kind of think about message passing, but how do you kind of introduce determinism or other various kind of proof systems for compression?
Yeah, I mean, I guess it depends on what you're trying to do, right? If you're trying
to the context of interacting with LLMs and specifically kind of token generation.
Right. Yeah, because if you're trying to the thing with ZK proofs, I mean, obviously, they have a significant overhead, but then also the question is what is the actual assurance that you're getting, right? And then because if a model was created by someone else, then you also wants to have assurances over what the actual model is that's doing the computation. You might want to have potentially other kinds of assurances as well. And then one of the challenges, of course, is that all of this is inherently competing against the the very natural alternative, which is to just do whatever computation you want it to do locally, right? And there's two valid reasons to not do that. One of them is hyperscale, but then with hyperscale, the problem is you can't do snarks. I mean, you could do TAEs because like the overhead is fairly low, right? But snarks you can't. And then the other reason is computing over private data. And like I think a lot of people are definitely interested in this use case of like trying to see, if you can combine, like private data from different participants, potentially like a private model from one participant with private data from another participant. I think there's definitely a bunch of specific applications where that makes sense. I mean, potentially, like you could even imagine it being used in something like deep funding, right? Like you could, imagine like something where like there might be models would be able to get input from individual participants, and like that feedback would be provided privately in some way where, I mean, there's some guarantee that the model can only use that information in some like very limited way, like basically extract like at most one bit of information. So I think like that's definitely an interesting intersection. Like the intersection of governance and privacy is definitely important. I mean, also even the intersection of governance and unprovability, right? Because I guess we've seen, right, governance gets taken over by bribes, and I mean, recently the other worst thing that's happening is like
What's the definition of unprovability? Like, what's the nuance here?
Oh, sorry. So this is the idea that like you need to provide an input to a governance mechanism in such a way that you can't prove which input you provided, even if you want to make the proof. So it's like basically the same as the Mesa use case, right? But like to me, I think about this as like basically any mechanism that is not a financial mechanism is a mechanism where it's valuable to have this kind of like limit to prove because you want like a limit to trade, right? And that's I mean, even public discourse is a good example, right? Like I saw a couple of days ago, like Hasu was complaining on Twitter that Kaito, which is this like Twitter leaderboard thing that like might have an airdrop, is like basically ruining crypto Twitter because people are optimizing for the algorithm, right? And like that's the same thing, right? Because like culture ultimately is a type of governance, right? And so it's the same sort of thing where like if you have a side input where the side input is offering you an incentive, then if you take the incentive, you're claiming 100% of the benefit, but then you're only suffering like 0.01% of the cost of like, like basically degradation of quality of discourse, right? And so the thing is unbalanced. So I think like, yeah, like I definitely think we need to explore unprovability more. And then, I mean, unprovability is also like a TE application because, I mean, as we saw in the complete knowledge paper, one of the use cases of a TE is basically using a TE to prove that you're not inside of another TE that's selling your account. Look, if you're going to be participating in something that involves like talking directly to an LLM, like the exact same sort of thing applies.
No, that makes a lot of sense. I think it's a good transition to sort of get ready for the next panel because ultimately governance and understanding how do we do things more interestingly on chain with AI is a pretty hot topic and actually relevant too because aptly named DAOs are missing the A.